Hello, welcome back one more time to something about Universal Robot Sim and Modbus. We are still looking at the build in Modbus. I have in my other videos shown how to use QMap. Here I'm showing just how to write with it. Again, for some reason I'm getting this error when I'm recording. Let's see if we can get a connection up and running. Always make a simple call first and then we will continue. I'm writing to a coil. This is the output coil. So basically it's possible for me to set some values. I have a small program running, a small pick and place program where I'm using digital output 0 to simulate something that is picked up or set down. One thing is to work with this small program, but one of the areas that can be quite interesting to get data over in is basically a program like Kepware. Kepware is a wonderful, simple, small program that actually has a lot of good drivers. What I will show you is how to set it up. As you can see, I already in my Kepware program is working with some Ethernet IP with from Allen Bradley, some OPC UA, where I'm having a OPC UA client that is talking to a server somewhere, and some codices. Right now, I will be making a new channel, and this channel is using the Modbus. When we are looking through some of the drivers in Kepware, there's many possibilities. I can recommend you to take a look if you need some communication for your project. What I'm going down towards is Modbus. There's different Modbus. There's the Serial Plus and so on. What we are looking at here is TCP IP. So I'm choosing driver. I'm calling it something. Let's call it something saying. Let's call it Modbus URSIM. Am I using a virtual network? I really recommend when you're working with it. It's quite good, but specifically when you are working with your network, I will recommend that you're choosing your driver. I'm working with I have bridged my virtual machine here with the URSIM directly to my Wi-Fi card that I'm sitting with. So I can recommend that you just is connecting directly to the card you know you're using. But default is very often also working. Basically, I'm not changing anything else in the settings all the way down, and there we have a simple driver. When you go into the driver, then there's no devices. This is just the Modbus we have connected right now. So you can click add one. Then let's call it URSIM, because then we know it's our simulator. What model it should be running? It's running Modbus, because that's what we were looking for. Then you're giving it the IP. In my case, it's 221. You can see that right over here. We are looking at what port it's setting up, timeout settings, and so on. Basically, one of the most important things is, of course, that you're using the correct port. By default, 255. You need to set that up in your firewall if you're sitting on a bigger network. I'm not looking that much into the default setting, and you can also call in data. But what I would like to do right now is basically to go in and add some addresses. Let's say that I would like to monitor the inputs for the system. That means that I will go to 40,000 and then a 0. And that's actually not completely correct when we're talking about Kepware. You should always remember that. So if you have any doubt, please press this address and you can see the different address. Because the address is always starting, we are looking at the register here, at 40,001. So instead of just 40,000 as a 0 and then add up, you need to take the 40,000 and then add whatever value. So 40,001 would be the input word that we're getting up here, the 16 bits. Let's take that one. Not that it's that interesting. Then we can take the output. And that one is as well is following 40,000. And if you're looking at the Universal Robots Modbus server addresses, it's 1, but we have already 1, so it will be 2. One thing that could be quite nice to do with the input output is saying that the input is read only, because it is a read only value as we have up here, while it's read and write for the output. There's other addresses that might be interesting to take a look at. One of them that I personally like to monitor is something like the position of the different joints. So let's add in some base. Let's say int base joint in micro radians. That will be 40,000, 71, because it's +1 from 40,001. This one is also just a read value. We can change that one because, and one other little thing that I can recommend is that you're giving your name for joints and number, because that will mean that they are coming in the right order. Let's say shoulder joint micro radians. Also read one. And we can continue like this. 3, that would then be elbow. I'm getting a little lazy here, so I might just take this part and just copy it so we're ready. 40,000, and that will then be 3. And we just let it stay as read write. By default, everything is words, which is quite nice. That's a 16-bit value that helps us a lot. What we now will do in Kepware, I can recommend that you are saying disconnecting and connecting in. It will update everything, but actually it should be ready. But specifically when you're setting up a new channel, that would be a better thing. We can't see anything special here. We can scale the values, we can see the scan rate. But what you're doing in Kepware is we are launching an OPC value. Here we have everything from our system, and what we are looking at is the Modbus value down here. So we're going down to our Modbus, the Modbus URSIM, that's the channel, and then the URSIM, that's our value. What we're looking at here is basically our different values with the given name. As you can see here, the input, the output, the different joints. We should be able to give them a better saying name by the numbers we just gave them. So right now we can look at the values of our different joints when it's moving back and forward. All of these values are updated as fast as it's possible. Right now, once a second it is updated. As we can see, some of the things are not changing that much, so we are not updating anything. There is no new value, so you can also see which joint you actually are using most. All of the values are also now available on the built-in UPC UA server running within Kepware. So you can continue these values in other settings, sending them up to a mesh system or ERP, whatever you want. We can change some of the values if it's possible. One thing we would maybe want to change could be something like our setting here. So you can see if I'm changing this value, of course, it will change quite quickly. I can also go in and make an asynchronous 2.0 write to this value. Let's say that we are writing 9 and applying the value, we will see that it will be sent over quite quickly. Now the current value is 3, and we are getting that value back. We can write 12, and the value will be changed. I actually think that's because we have this qmod sending values in the background. So let's say 12. Now we can see that it's changing our values quite quickly, and but even while we are applying it, it's a single write. You'll see that 0 still is changing because of the program itself. So that's how you can set up your data and get your data from your universal URSIM or to a program like Kepware. using Modbus. There is other possibilities also, but now the data is available. Kepware can be used for 2 hours, 2 hours for straight out for free. And when you then you will get an error and it will stop working. Then you can restart it and it will continue to work for 2 hours. If you need more than that, you need to buy a license. So that's a little guide on how to use Kepware with Modbus.